Today is an important day because we are going to start writing proofs about geometry, okay? We spent a couple days, you guys got really good at proofs about algebra, but now we're going to talk about proofs involving geometry. So our first hurdle are segment proofs. So just segments, okay? Okay. So we still have equality properties, okay? Addition, subtraction, multiplication, division, distributive, all of these we still have, but you can only use them when there are equal signs. If they are not equal signs, like maybe it's a congruent sign, we have properties for congruence. We have properties for equality, okay? Now, I will tell you that when there's the congruent sign, we do have the reflexive property, okay? That is a thing. We also have the symmetric property. So if AB is congruent to CD, then we can write it the other way. Thank you. And we have the transitive property. All right, so AB congruent to CD, CD congruent to EF, then we can say AB is congruent to EF. Okay, so those three properties, we have them for equality and we have them for congruence. Okay. Now, what if we want to use the addition property or the subtraction property or the whatever? What if we need to use one of these properties, but we have a statement that involves the congruent sign? Okay. Let's talk about the definition of congruence. So first of all, the definition is a biconditional statement, which means it's one of those if and only if. So segments are congruent if and only if they have the same measure. So this is what we know. The definition of congruence: if AB is congruent to CD, then we know that their measures are equal. So if we have a congruent statement and we need to somehow use one of our equality properties, then we can change it to an equal sign using the definition of congruence. Or maybe we have an equal sign statement and we need to change it to congruence. That's fine. If AB equals CD, then we know that means they're congruent. Now, we can use our prior knowledge to help us with our proofs. So tell me, What does it mean if M is the midpoint of AB? What is M creating? Conway?
Never mind.
What were you thinking?
I was gonna say, segment bisector.
Well, it is a segment bisector. So if we have a segment bisector, what's happening with our segment?
Creates two congruent segments.
Okay, we have two congruent segments. So if M is the midpoint of AB, then AM would be a segment that would have the same measure as MB. Okay? So if we ever have a piece of given information that says M is the midpoint of AB, then one of our statements, are you okay? One of our statements can be this right here, and our reason, the definition of a midpoint. Okay. All right. We also have something called the segment addition postulate.
Can I give a guess on what it means?
Sure.
So, with that, I think it is AB plus BC equals AC.
Okay. How do you feel about what Alex gave us? Confident? Okay. Here we have AB. Here we have AB plus BC equals AC. Yeah? Yeah?
I agree.
Okay. It is an equal sign. Notice there's no hats, there's no congruent sign. Okay? Now, not every time are you going to need to use this. However, if you have a segment with 3 points, it might be helpful. Maybe, maybe not. Okay? Okay. Go to the next page.
I like
What?
Remember that awesome catch in class?
Yeah, I'm pretty excited about that.
Yeah.
Wait, about
Yeah.
I hate it when you caught in the little.
So that bag of balls, I was holding it,
Yeah,
and
I was
she
far away.
boom, hit the ball, and I caught it in the bag.
Yeah.
It's
It was
pretty
pretty
sweet.
awesome. You wish you seen it.
Can I have the fair
Oh yeah.
The third
who were
donut
those
is gone.
donuts for?
Oh, I thought they were.
People who won the game in my evasion. But they really were for the teachers on our team, and they were left over, so I used them. Your brother got one. Oh, he's not very happy about it. I'm sorry.
It's okay.
All right. So problem number 1. E is the midpoint of DF is our given information. So the first thing we do is what? We write down that we have our given information. Okay. So these first 2 proofs, I already have like the steps laid out. Okay. And we need to reason through why it would be the next step and what the reason would be. Okay. So let's just think about. I'm really sorry, but that's really distracting for me. Think you could put those away? Thank you. If E is the midpoint, and here's E right here. If E is the midpoint, what does that tell us about these 2 segments? Ollie?
Well, since E is the midpoint, DE plus EF, or DE equals EF. So, it's the definition of midpoint, that's the reason.
Okay, so we know that if E is the midpoint, then these 2 segments are equal, right? So we wrote down that DE is equal to EF, and Ollie is trying to spit out that our reason is definition of midpoint. Yes. Now, instead of writing the whole word definition, are you okay if I abbreviate to DEF?
Can we do that on a test?
I would absolutely be okay with that.
Yes.
Okay? But if you're somebody who likes to write out the whole word, you go for it. Okay? Now, our whole goal here is to try to prove that 2DE equals DF. So 2 DEs equal DF. That's what that's saying. Does that seem like a reasonable thing? Okay, so notice how our very last step matches what we're trying to prove. Okay, now, we are probably going to need to use well, I think some of you are like looking ahead, right? So we're going to have to do something to where we get 2 DEs. Okay? So notice how we took this right here, DE equals EF. And what happened to both sides? We added a DE to both sides. What do we call it when we add something to both sides? Property. If you write prop for property, I'll be cool.
I do add problem.
Add prop, that's cool too.
We
Okay?
did the same thing with the other properties. Maybe
Yeah.
not distribute, but
Yeah. If you need to abbreviate a little bit, I'm cool with that. I know it gets annoying. Okay? Now, what happened from this step to this step? DE plus DE equals 2DE. Okay, so just to be easier, I'm just going to write the word simplify. Okay, I'm going to write the word simplify. Are you writing this along with it? Like combine like terms? Yeah. Okay. Now, let's pretend that you can't see this right here. Okay? I need to somehow get DE plus EF, and I need to get it to where it's DF. Do you see that? Okay? So I'm going to just highlight the picture. I know you have an idea, and I love it, Josh. So we need DE plus EF to somehow morph into DF. Josh, what's your idea? Not quite yet. Not quite yet.
Subtraction subtract. So the subtracting one.
Conway.
Is it the sigma? Segment addition property.
The sigma property.
The segment addition postulate says that segment plus segment equals the whole segment. There it is. Okay? So DE plus EF equals DF. Okay? Now, Joshua, do you see how we have what? Lucas. So do you see DE plus EF here and DE plus EF here? So combining these two steps to get to here, we use the transitive property.
Is it the same thing but with more terms? What we did last time with more terms?
Yes. Okay. Yes.
why did they put two? Why is it two?
Wait, because DE and EF are congruent.
Okay, so what'd you say, Avery?
I said why did they put the same?
What do you mean? Like these are now equal. I don't, did I not answer your question?
I think she's trying to mean like because you already used the EF, why is there still one on the other side?
Well,
This guy?
Why is it the D plus EF on the other side of equal?
why is it D from one side and then it switches to the other? What you
This
said,
one?
DE plus EF equals DF.
Okay, so we could have written it the other way. Okay, but typically when we think of the segment addition postulate, we talk about little chunk plus little chunk equals big chunk, right? So when we write it like this and these two match, we can call it the transitive property. Now, what is another property we could have used instead of the transitive property? Because we took this and we replaced it with 2DE.
Substitution.
Substitution. We could have said substitution and that would have been fine. Okay. Okay. Deep breath. Hayden, are you stretching or do you have a question? Okay. Also, before we keep going, you accidentally said sigma.
Yeah, that's me.
Could you give me the definition of your meaning of sigma?
I don't know. Yeah, what she said,
Like the best, right?
Yeah.
Like,
Sigma is like saying it. She's gonna start saying it.
Everything means everything.
The best. It's me.
Just walk up.
that's what I,
Walk up
okay.
to all of your teachers and just say, "I'm Sigma."
Okay, so this is what I've been trying to describe to my husband. He teaches at the high school, and he has seniors in his statistics class. And did you know that sigma is a Greek alphabet letter,
Yeah.
right? That is used in statistics, okay? And they keep giggling about it, and he was like, I think it means something inappropriate. I was like, no, it doesn't. He's worried about it.
I'm
But
excited for your sister.
so the capital sigma is used to like sum up numbers. The lowercase sigma is used for standard deviation.
I'm a higher case Sigma. He's a lowercase Sigma.
Oh, great. Now I've given you more. Okay.
Yo.
And moving on. So, yes. Okay. So for those three people who aren't here, our code word is sigma. We'll see if they watch the video.
You mean sigma for what? Like,
I'm recording.
you're recording right now?
Where's the camera at?
Wait. It's on.
It's
On
this.
there?
Wait,
No,
they can
I didn't know
She got
you.
rid of
Yes.
Hello! I'm gonna go back to the video and watch myself.
Didn't I?
No one is not watching the video.
Okay. Let's look at number 2. Our given information is that KL and LN are congruent. Our other information is that LM and LN are congruent. We want to prove that L is the midpoint of KM. Does it make sense that that is a legitimate thing?
Yes.
If these two are congruent and these two are congruent, then I bet we're going to be able to show that these two are the same. Ergo, L is the midpoint.
Oh, I get it.
Okay? So, let's start out with our given information. Okay? I don't think... Okay, so now what happened from step 1 to step 2? What did we do? Since we took since we took away the congruent signs and the hats, it's the definition of congruence. So instead of writing the word congruence, you're probably going to spell it wrong anyway. I just made the congruent symbol. Are you okay?
COGRUENT.
What happened?
I thought myself the eye.
I need myself in the eye.
In gymnastics, did you see that gymnast that fell off the bars at the Olympics and she kneed herself in the eye, like gave herself this big black eye, and it was just during warm up, so then she had to keep going? Okay. So now, the reason we had to change it to equal signs is because of the properties. KL is equal to LN. LM is equal to LN. So if I go to KL, stop talking while I am, is equal to LM, what property did we use? I disagree.
Is it substitution?
Why is it substitution and not the transitive property?
Because substitution subs it in. It's not like
Okay, so these aren't in the right order. Hey, Alex, I want you to just look at this. These would need to be flipped around, and like these two have to be the same. Okay? Now, here's the deal. I get that the transitive property and substitution property are very close when something like this happens. So, Alex, if you would have told me transitive property on like a quiz situation, I'm probably not going to get upset because I know what you're going for. Okay? But technically, this is substitution. Now, if I have this segment and this segment are the same, then we know by the definition of midpoint that that middle dot is a midpoint. If you put MP, I will know it's midpoint. Okay. Now this is where it really gets exciting. Everything's blank.
I'm okay.
You're okay?
Yeah.
I go down to
Oh,
Are
it's
you?
like, it's like the same thing as this one because it's like the two in the middle and then like that one.
Okay, so what is the first thing we should do with any proof?
Prove it.
We need to write the given. PQ is congruent to TQ, and UQ is congruent to QS. Given. And you know what I'm going to do? I'm going to look at my picture. UQ is congruent to TQ. Huh. Wait, hold on. No, sorry. I read it wrong. PQ is congruent to TQ. And UQ is congruent to QS. There we go. So I want you to just look at that picture. Our goal is to prove that PS and UT are congruent. Does that seem plausible?
Yes.
Okay, I think it sounds plausible. What item from page 11 do you think is going to be super helpful in this?
Symmetric property. Segment addition postulate.
The segment addition postulate is probably going to be helpful because right now we have a bunch of little chunks and we want to prove that the big pieces are the same. Now I have a question. Does the segment addition postulate have congruent signs?
No.
Tell me.
No.
No.
No. So the first thing that I think we should do is I think we should change all of these to equal signs instead of congruent signs, using the definition of congruence. Okay? Okay. Now, Conway gave us a suggestion, hey, let's use the segment addition postulate. Let's do that. We know that PQ plus QS equals PS, and we know that TQ plus QU equals TU. I don't know. It's Mr. Carlson's class. He's the science teacher for the Hurricanes.
L group. Whoa, that's not very nice.
That's not nice.
I don't know what you said, but we're going to ignore it. Okay. What the heck are we going to do to show that PS and TU are the same? Hayden, do you have an idea?
PQ plus QS equals QU plus TQ. What?
So that, okay, so we can't say that right now. But if we can get to that sort of place, it's kind of what we're going for, right?
Well, yeah, basically that, because like PS had like PQ and TQ, but both are congruent, so they have the same distance, and
Okay.
TQ and PS both have the two congruent roots.
You see this right here, right?
3 lines equals 3 lines.
Since PQ and TQ are the same, then we can take this statement and we can replace PQ with TQ. You see that? I replaced PQ with TQ. What's that called when I replace? Okay. I also see that UQ and QS are the same. So I can take this guy right here and write that TQ plus I can trade QU for QS equals TU.
Did you put up the same one?
You could. I was just trying to like really make it simple for you. Okay. Oh my goodness.
It's the same thing.
Oh my goodness, they're the same thing, aren't they?
Wow.
These are the same thing. So could we say
PS equals CQ.
that PS equals TU? Could we do that?
Yes.
You betcha.
It's like the definition of congruence.
Ah, Conway, you're so good.
I just said that before.
I didn't hear you. I'm sorry.
I didn't hear you either.
Conway said, "Hey, now that we have this, we can use the definition of congruence to get our congruence sign back." Yeah, that's fine. And if you accidentally called number 6 the transitive property, I'm not gonna get upset about it.
What's a transitive though?
A equals B, B equals C, so A equals C. You asked a question, then you didn't listen to the answer. Okay, so this is what you're gonna start working on. Page 13 and 14 is your homework. I think you only have one proof to do on your own. Yeah?